Good day, everyone. We're going to tackle about representation of function. What is a relation? A relation is a set of ordered pairs. The domain of a relation is the set of first coordinates. The range is the set of second coordinates. Take a look of this given example in a tabular form. We have here the values of x, -2, -1, 0, 1, and 2. And the values of y, we have 4, 5, 6, 7, and 8. And now we are going to identify what are the domain and what are the range. So we have here the domain, -2, -1, 0, 1, and 2. And the range, 4, 5, 6, 7, and 8. So what have you noticed? The domain are the values of x, and the range are the values of y. Another question is, what is a function? It says here that the function is a relation in which each element of the domain corresponds to exactly one element of the range. Example, we have here the domain, Jane, Jonah, Jacob, and Joshua. And the range, 1, 2, 3, and 4. So Jane is paired to 1, Jonah is paired to 2, Jacob is paired to 3, and Joshua is paired to 4. So this is called a function. We have three kinds of relations. One-to-one relation, one-to-many relation, many-to-one relation. A relation F is one-to-one if one element in the domain corresponds to only one value in the range. A relation F is one-to-many if one element in the domain corresponds to two or more values in the range. And a relation F is many-to-one if two or more elements in the domain corresponds to only one value in the range. Let's consider the following example. The domain, we have Rain, Ella, and John Will. The range, pink, red, and blue. Rain corresponds to pink, Ella corresponds to red, and John Will corresponds to blue. So each of the elements in the domain corresponds to one exactly element in the range. And this is called a one-to-one relation. How about this? The domain is only Anne, and the range, we have mango, apple, and banana. Since Anne is the only domain and she is paired to three elements in the range, that is one-to-many relation. The third is many-to-one relation. The domain here, we have Jake, John, and June. And the range is only basketball. So we have many elements in the domain, and there is only one element in the range, that's basketball. So that is a many-to-one relation. We have also a vertical line test. So where can we use this vertical line test? A graph represents a function if and only if no vertical line intersects the graph in more than one point. So this vertical line test is being used to test a graph if that graph represents a function or not. Okay, example, you look at this graph. This is a parabola. And we have to test this graph if this is function or not. Is this the function or not? We will use a vertical line test. It hits only one point, that is the function. How about this graph? You look at the orange vertical lines and it only touched the graph at one point. So this is also a function. How about this graph? Is this a function? You look at the arrow. It hits 2 points. So this is not a function anymore. Now, a linear function f is a constant function if f of x is equal to mx plus b, where m equals 0 and b is any real number. Thus, f of x is equal to b. So that is the slope-intercept form. The m there represents the slope, and b is the y-intercept. So the formula, if that is constant function, is f of x is equal to b. For example, we have f of x is equal to 3. The value of y is always 3. That is why it is called constant function. It never changes. It is always 3. Next is a linear function is an identity function. F of x is equal to mx plus b, where m is equal to 1 and b is equal to 0. So if the slope is also 1 and there is no y-intercept, thus f of x is equal to x, and that is an identity function. The third is the function f is an absolute value function if for all real number x, we have f of x is equal to positive x for x is greater than or equal to 0, and negative x for x is less than or equal to 0. And the next function is a piecewise function. What is it? A piecewise function or a compound function is a function defined by multiple sub-functions, where each sub-function applies to a certain interval of the main function's domain. Okay, these are the examples of a piecewise function. We have f of x is equal to x plus 2 if x is less than or equal to 0, and x if x is greater than 0. G of x is equal to 2 if x is equal to 1, and 0 x is not equal to 1. And h of x is equal to x plus 1 if x is greater than 5, x only if x is equal to 5, and x minus 1 if x is less than 5. So with these given functions, there are multiple sub-functions. These are called piecewise functions. Consider this real-life situation. You are a crew at Acts 12:7 convenience store pays an hourly wage of 45 pesos and 1.5 times the hourly wage for the extra hours if you work for more than 40 hours a week. Write a piecewise function that gives the weekly pay in terms of the number of hours each you work. If you're working for over 40 hours, your pay is given by 45 times 50 plus 1.5 times 45 times h minus 40. So this will be the formula being used to compute your salary if you work for over 40 hours. So 45 times 50 is 1,800 plus 1.5 times 45 is 75 times h minus 40, and we will apply here the distributive property. So we will distribute 67.5 to h minus 40. So 1,800 plus 67.5 times h is 67.5h minus 67.5 times negative 40. So we have minus 2,700. And we will simplify, combine like terms. We have like terms 1,800 minus 2,700 is minus 900. So this formula will be used in computing if you work for over 40 hours in that convenience store. Thus, the piecewise function is P of h is equal to 45 times h. If h is greater than or equal to 0, but less than or equal to 40. And we have 67.5h minus 900 if h is greater than 40. So if you're working 30 hours only, the formula in computing your salary is 45 times h, meaning 45 times the number of hours you work. But if you're working 50 hours, the second formula is being used in computing your salary. We have 67.5 times h minus 900. So this is a real life situation in which we can apply the piecewise function. Now we have also the horizontal line test. This will be used in testing a graph if it is one-to-one or not. So a function is one-to-one if no horizontal line intersects its graph more than once. You look at these two graphs here. The first is V and the other one is it's a line. So if we are going to use the horizontal line test, I mean, the first graph we have 2 points being hit. So this is not a one-to-one. Here at the other graph, it only hits 1 point. So this is a one-to-one function. Okay, determine whether each graph represents a one-to-one function. Letter A is one-to-one. Letter B is not. Letter C is one-to-one. And letter D is not. Because in letter A, if we'll use the horizontal line, it hits 1 point only. Letter B is 2. Letter C is also 1. And letter D is 2 points. So that is how to determine if a given graph is one-to-one or not using the horizontal line test. Now we will go to the evaluation of functions. What is the meaning of evaluation? Evaluation means we are going to get the value of a given function. We have the law of substitution here. A plus x equals b and x is equal to c, then a plus c is equal to b. The function notation y is equal to f of x tells you that y is a function of x. Again, the function notation for y is f of x. So f of x and y are the same. And it will tell you that y is a function of x, meaning y depends x. That's the meaning of the word function there. The y depends the value of x. We cannot get the value of y unless we will give the value of x. Example, if f of x is equal to 3x plus 1, find f of 4. So meaning, the value of x is 4. So we have to replace or substitute the place of x with 4. And 3x means 3 times x. So we have to multiply also 3 and 4. So 3 times 4 is 12 plus 1 is 13. So we have here, if the value of x is 4, we can get the value of y. We have 13. The ordered pair is 4 and 13. So we can get 13 if our value of x is 4. That's evaluation. And how to evaluate the function? Example, f of x is equal to x plus 8. So the given function is x plus 8. And we will evaluate each. There are 4 different values of x here. The first one is 4. The second is negative 2. The third is x plus 3. And the fourth is negative x. So in letter A, we will substitute 4 in the place of x. So we have 4 plus 8 is 12. So if x is 4, the y is 12. Letter B. If x is negative 2, so we will substitute the place of x with negative 2. Plus 8 is 6. Again, just a review. To add integers with opposite signs, what shall we do? We have to subtract and copy the sign the integer with the greater absolute value. So 8 minus 2 is 6. And 8 is a greater absolute value than negative 2. So we will carry the sign that is positive. Or, to be easy, if you are going to add integers with opposite signs, just apply the bayad and the utang principle. The negative numbers are the utang and the positive number is the money. So if you have utang 2 and you have money 8, you have still money 6. Letter C. We have x plus 3. So just substitute the place of x with this binomial x plus 3 plus 8. And 3 and 8 are like terms, so we can combine them. 3 plus 8 is 11. So we have x plus 11. And letter D, we have negative x. So just substitute the place of x with negative x. And then plus 8. So that is how to evaluate a function. Now look at this function machine. We have here the input, then the function machine here at the center, and we have the output. So we will consider that the x is the input and the y is the output. Now, what is the given function for this? So we have the input 23, 29, 38, 17, 46, and 19. And we are going to get the output. And here, the function machine is plus 4. So we need to add 4 everything. So 23 plus 4 is 27. Next is 29 plus 4 is 33. 38 plus 4 is 42. 17 plus 4 is 21. 46 plus 4 is 50. 19 plus 4 is 23. So that is how we will apply the input and the output. Remember, the input is the value of x and the output is the value of y. So if it is written in a function notation, f of x is equal to y and y is the function of x, meaning y depends the value of x. Now we will go to the operation on functions. So we have here the product rule for exponents, the power rule, the power of a product rule. And this is just a review of your algebra and your junior high school lesson. So if you're going to multiply algebraic expressions with the same basis, just add their exponents. But if you're going to simplify an algebraic expression and another exponent outside, so just multiply the exponents. So that is why x m n, or x to the power of n times n. And we have here also the power of a product rule, xy to the power of m. So we have x to the power of m and y to the power of n. Now we will talk about the FOIL method. I know you're familiar with this. And this is being used in getting the product of two binomials. So we have here 2x plus 3 times 5x minus 8. So in FOIL method, the f represents the first terms, the o represents the outer terms, and the I represents the inner terms, and the L represents the last terms. So here, in this example, we have the first terms are 2x and 5x. You multiply them, 2x times 5x is 10x squared. And the outer terms, we have 2x times negative 8 is equal to negative 16x. And the inner terms are 3 and 5x. You multiply them, that is 15x. And 3 times negative 8 is equal to negative 24. So the final product for this, we have 10x squared minus x minus 24. It becomes minus x at the middle term because we combine negative 16x and 15x because they are like terms. So negative 16 plus 15 is negative 1x. So the final product is 10x squared minus x minus 24. The next is the square of binomial. So there are 3 steps that you are going to follow if you are going to find the product of the square of binomial. Example, we have 2x minus 4 squared. So the first term is 2x, the second is negative 4. And here we are going to square. The first step is square the first term. So we have 2x squared. And 2x squared is 4x squared. Twice the product of the 2 terms is the next step. So twice means 2. So 2 times 2x, which is the first term, and negative 4 is the second term. So 2 times 2x is 4x times negative 4 is negative 16x, because the product of integers with opposite signs is negative. And the last is square the last term. So negative 4 is the last term. Negative 4 squared is positive 16, because the product of integers with the same sign is positive. So the final product of 2x minus 4 squared is 4x squared minus 16x plus 16. And we have here the cube of binomial. There are 2 formulas that you are going to follow. If the given is all positive, the first and the last terms are all positive, so the product are also positive. Each term has the positive sign. But if the last term is negative, so the product has alternate signs. Positive, negative, positive, negative. And we have constant here 3 and 3. So meaning x plus y cubed is equal to first term x. You have to cube it. Next, plus 3. Square the first term times the last term, plus another 3 times the first term times the square of the last term plus the cube of the last term. And same process with the next formula, but the sign is alternate. So we have to find the product of 2x plus 3y cubed. Okay. We have to cube the first term, which is 2x. So we have 2x cubed plus 3 is constant here. The square of the first term, which is 2x, so 2x squared times the last term, which is 3y, plus 3 times the first term times the square of the last term, which is 3y, plus the cube of the last term. This is 3y cubed. And we need to get the product. We need to simplify them. 2x cubed is 8x cubed, because 2 times 2 times 2 is 8. And 3 times the square of 2x is 4x squared. So 3 times 4x squared is 12x squared times 3y is 36x squared y. And we have here 3 times 2x is 6x times the square of 3y is 9y squared. So 6x times 9y squared is 54x y squared. And the cube of 3y is 27y cubed, because 3 times 3 times 3 is 27. Okay. Same example with the negative 3y, the last term. We have the same answer, but the sign is alternate. We have positive 8x cubed minus 36x squared y plus 54xy squared minus 27y cubed. Next is the product of sum and difference. So x plus y times x minus y. So we have plus and minus. That is why it is called product of sum and difference. And the formula is x squared minus y squared. Example, find the product of x minus 10 and x plus 10. So square x minus the square of 10. So x squared is x squared minus 10 squared is 100. So the product of that is x squared minus 100. We have also here the square of trinomial. Trinomial means 3 terms. X plus y plus z. There are 3 terms there and we need to square. So there are how many steps here? 1, 2, 3, 4, 5, 6. The first one is square of the first term. So the first term is x, so you need to square x. So that is why x squared. Next step is square of the second term. The second term is y, so you need to square y, and that's y squared. Next is square of the third term. The third term is z, so we need to square z, that is z squared. And we have to get the twice the product of the first term and the second term. So twice means 2. So that is why there is plus 2. And the first term is x times the second term y. Next is twice the product of the first term and the third term. So that is why we have 2xz, because the first term is x and the last term is z. And twice the product of the second term and the third term. So we have twice is 2. The second term is y and the third term is z. So that is 2yc. So it depends upon the signs also. And here in this example, is there also the product are all positive also. Now we will go to the sum, difference, product, and quotient of functions. We need to add, subtract, to multiply, and divide functions. So we have 4 formulas here that we are going to use. The first is sum. So function f plus function g of x is equal to f of x plus g of x. F minus g of x means f of x minus g of x. And f times g of x is equal to f of x times g of x. And the quotient is f divided by g of x is equal to f of x divided by g of x, where g of x is not equal to 0. Why? Because g of x will be 0, then it will be undefined. Example, we have 2 functions here, the f of x and the g of x. So the f of x is equal to 3x minus 2, and the g of x is x squared plus 2x minus 3. Letter A, we need to find the sum of the 2 functions. F plus g of x is equal to f of x plus g of x. So we need to add the 2 functions. And we have 3x minus 2 plus x squared plus 2x minus 3. And we need to combine all like terms. So we have 3x minus 2 plus x squared plus 2x minus 3. Since there is only one x squared, so we have to copy it. And then we have 2x here, the 3x and the 2x, so we need to combine them. That is 5x. And we have also negative 2 and negative 3, and that is negative 5. So if we are going to add these 2 functions, the sum is x squared plus 5x minus 5. If we are going to subtract, okay, the same principle, we have to combine like terms, but we need to get the opposite signs of the subtrahend. So the subtrahend here is the g function. We have x squared plus 2x minus 3. And the minuend is 3x minus 2. So we will not change the sign of the minuend. So the same 3x minus 2. And then we will change positive x squared to negative x squared, positive 2x to negative 2x, and negative 3 to positive 3, because that's the principle in subtraction. So combine like terms here. We have negative x squared only. So just copy. And then 3x minus 2x is positive 1x, and negative 2 plus 3 is positive 1. So that is the difference. The third is the product of the two functions. And we will apply here the distributive property. We will distribute 3x to x squared plus 2x minus 3. So 3x times x squared is 3x cubed. 3x times positive 2x is positive 6x squared. And 3x minus 3 is negative 9x. So why it becomes cubed? Because we have 1 plus 2 is 3. And it becomes x squared here because 1 plus 1 is 2. And in the other side, we have negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times positive 2x is negative 4x. And negative 2 times negative 3 is positive x. And we need to combine all like terms. Like terms mean the same variables and the same exponents. So we have here, there is only one variable that has 3 exponents. So just copy it. Just copy 3x cubed. And we have 2x squared here. So positive 6x squared minus 2x squared, and that is positive 4x squared. And we have here negative 9x and negative 4x. So combine negative 13x. And we have only one constant, and that is positive 6. So just copy it. So the final product is 3x cubed plus 4x squared minus 13x plus 6. And the quotient is just copy the whole function. We have 3x minus 2 divided by x squared plus 2x minus 3. And we factor the denominator. We have x plus 3 and x minus 1. Now we factor the denominator to get the restrictions. So x plus 3 is equal to 0. So x is equal to negative 3. And the other one is x minus 1 equals 0. So x is equal to 1. So the domain of that given function is x are all real numbers except negative 3 and positive 1. So we will go to the composition of functions. This is the symbol for composition. So f composed with g of x. So that is the formula being used. The domain of the composition is the set of all x such that, number 1, x is in the domain of g and g of x is in the domain of f. Okay, look at this example. We have the given f of x is equal to 4x minus 5 and g of x is equal to x squared plus 4. And we need to find the composition of f and g. So we have here the f of x is 4x minus 5. And we will compose the two functions. So we have 4 composed with g of x minus 5. So meaning you have to replace the place of x with the whole function g of x. So that is why we have 4. Replace the x with the whole function g, which is x squared plus 4, and then minus 5. Then you simplify, you apply the distributive property. So 4 times x squared is 4x squared, and 4 times positive 4 is positive 16, minus 5. And you need to combine 16 minus 5 is their like terms. So your final composition is 4x squared plus 11. Next example is g composed with f of x. So again, our g of x is x squared plus 4. And our f of x is 4x minus 5. So you look at here in the given function g. The x here is squared. And you have to replace that x with the whole function f, which is 4x minus 5. And you need to square it because in the function g, the x is squared. And then plus 4. And we will apply the 3 steps here in getting the product of squaring to the squaring of the binomial. We have simplify this 4x minus 5 squared. So 4x squared plus 2 times 4x times negative 5 plus negative 5 squared. So we have here the square of 4x is 16x squared, and 2 times 4x is 8x times negative 5, that is negative 40x, and the square of negative 5 is 25 plus 4. And you need to combine like terms. So there are 4 terms here, and the like terms are 25 and 4. So copy 16x squared minus 40x plus 29, because 25 plus 4 is 29. So that is composition of function, meaning you have to compose the 2 functions. Just replace the place of x with the whole function. Now we will go to the inverse function. If f is a one-to-one function, then the inverse of f, denoted by f negative 1, is the function formed by reversing all the ordered pairs in f. So example, find the inverse of the function 0, 1, 1, 2, 2, 3. So we have to switch the places of the x and y. So we have 1, 0, 2, 1, and 3, 2. Now there are steps of getting inverse function. Our relation, reversing the process performed by any function f of x, is called inverse. So we have to find the inverse of x. There are 4 steps to follow. Replace f of x with y, interchange x and y, solve for the new y from the equation in step 2, and replace the new y with f negative 1 of x if the inverse is a function. Example, find the inverse of f of x equals 3x plus 1. We will follow the first step. Replace f of x with y. So we have y equals 3x plus 1. Then interchange the x and y variables. So we have x is equal to 3y plus 1. And you solve for y in terms of x. So at the left side of the equation is x. At the right side is 3y plus 1. So to eliminate this plus 1 here at the right side of the equation, so we need to apply the subtraction property of equality. So whatever number we're going to subtract at the left side is the same number we're going to subtract at the right side of the equation. So we have x minus 1 is equal to 3y plus 1 minus 1 is 0. So we have already here x minus 1 is equal to 3y. But we need to find 1y. So since 3 is together with y, we need to apply the division property of equality. So whatever number we're going to divide at the left side is the same number we are going to divide at the right side. So since 3 is together with y, so we need to divide both sides with 3. So we have x minus 1 divided by 3 and 3y divided by 3. So we have here y is equal to x minus 1 over 3. Then the last step is replace the new y with f negative 1 of x if the inverse is a function. So we have here the inverse of f of x equals 3x plus 1 is f of negative 1 of x is equal to x minus 1 over 3. Okay, another example is find the inverse of 2x plus 3. So we have f of x is equal to 2x plus 3. So replace f of x with y. So we have y is equal to 2x plus 3. And we need to interchange the places of x and y. So we have x is equal to 2y plus 3. And we need to solve for y. 2y is equal to x minus 3. And we divide both sides by 2. And we have here the new equation. Y is equal to x minus 3 over 2. So the inverse function of f of x equals 2x plus 3 is x minus 3 over 2. Again, we will review the steps of getting the inverse of a function. Replace f of x with y. Interchange x and y. Solve for the new y from the equation in step 2. The last step is replace the new y with f negative 1 if the inverse is a function. Y is a function of x, meaning y is dependent with x, or we cannot get the value of y if we will not put value of x. So that is why y is the function of x, meaning y depends with x. And our spiritual life will represent x as God and y as human. So as humans, we're like y, dependent to x, which is God. So we will entrust everything to God because without him, we can do nothing. I hope you have learned something today.